In the last session, we gave a very brief introduction to the concepts of inquiry and integration and illustrated inquiry with a large number of cases. How do we look for answers to questions? How do we justify our conclusions and so on? What we're going to do today is to look at two kinds of inquiry, mathematical inquiry and scientific inquiry, and look at the differences between the two and the similarities as well, in terms of the way they prove that a conclusion is true.
So we're talking about justification here.
Justification.
Not
Actually,
about discovery.
No, actually it may be a good idea to mention the two aspects of inquiry. So in the last session, we said that inquiry has the following components. Let's write that down to remind you. Inquiry begins with a question. So for example, a question such as, what's the size of the universe? What is the age of the universe? Is there a correlation between, let's say, smoking and cancer? Does smoking cause cancer and so on? These are all inquiry questions. And it goes through a process of inquiry. And arrives at answers and conclusions. That's what we sketched in the last session. This process involves the process of discovering the answers, arriving at the answers, and having arrived at the answers and the conclusion, the process of justification. Justification means the inquirer has come up with a conclusion, but now the inquirer has to convince the skeptical jury of other inquirers that this conclusion should be accepted. Conclusion is quite legitimate, it's good, it's true, and so on. So what we are going to do is to look at this issue of justification. How do you convince the others in rational inquiry that the conclusions that we have arrived at, they should also accept?
And we're going to concentrate on two modes of inquiry, mathematical and scientific.
So we're going to look at mathematical proofs and scientific.
What we're leaving out here is things like moral proofs and stuff, which we kind of touched on in the last session. But our concentration here will be on these two.
Yeah. So shall we take some examples and
let's
show how this is done? So let me say this about, I have to introduce myself to the audience, right? So I was born in a village, and when I was born there was no electricity in the village. There were not even any roads and so on. And I distinctly remember that on my 5th birthday, my maternal grandmother was born. It was a huge celebration.
Okay.
We all celebrated. I was so rejoiced.
On your 5th birthday,
on my 5th
your
birthday,
maternal grandmother was born.
That's right.
Okay, that seems weird.
Why is it weird? So on my 4th birthday, one of my cousins was born.
That's fine, that's fine.
So same way, my maternal grandmother was born on my 5th birthday. What's the big
There's
deal?
a difference between those two, right?
Yeah, of course there is. One is a cousin,
And
the
one
other
is
is
a
my
grandmother.
maternal grandmother.
Yeah.
This could be my brother.
Yeah.
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 Or my friend's mother.
Yeah.
So if I said something like, my friend's mother was born
When you were 5 years old, that's possible.
Okay, let's discuss that later.
Yeah.
But anyway, you will agree, or let's say my friend's cousin was born.
Yeah,
You will-
that's perfectly fine.
Right, okay. Why is this bad?
Oh, because it implies that your grandmother is younger than you.
That's right. She is
Your maternal grandmother is
5 years younger than me.
Are we talking about your biological maternal?
Biological, yeah, that's right.
Okay, so the person
My
who
biological mother's biological mother.
is younger than you.
That's right.
And your mother
My mother was born after that.
was born after that.
Yeah.
Okay, so your biological grandmother gave birth to your mother after she was born.
Yeah,
Okay. And you were born before both of them.
that's right.
Okay. That doesn't seem possible.
Look, you were not born, I'm much older than you, right?
Yeah.
When I was 5 years old, were you around?
No.
When my maternal grandmother was born, were you around?
No.
So how do you know?
Because I know that maternal grandmothers can never be older than their grandchildren.
How can
Can
you?
never be younger than their grandchildren.
Do you have any proof for that?
I think I do.
Okay, so can you prove that nobody can exist? For nobody,
Yeah.
is it the case that that person's maternal grandmother
Yeah,
is
biological maternal.
yeah.
So, if we start with the premise, let's see if you agree with this, that let's start with the definition of a maternal grandmother.
Yeah.
Okay. Maternal grandmother is some.
Well, for the viewer's sake, let's like that's grandmother. Grandmother.
Okay.
Yeah.
Is the person who gave birth to your mother.
Yeah. Why? Well, actually, it's slightly easier to say maternal grandmother is your mother's mother, right?
Okay.
That'll be easier, right?
Yeah.
So why don't we do that? Where is that? So maternal grandmother is your mother's mother.
Yeah.
Yeah.
Okay. Then what is mother?
Okay. Biological mother is the person who gave birth to you. So these are the definitions.
Okay. So you're saying that your maternal grandmother gave birth to your mother. You
Right.
accept that?
Yeah.
And your mother gave birth to you.
That's right.
So now how can your maternal grandmother be younger than you?
Because the giving birth happened much later.
The giving birth happened after you were born.
Yeah.
Oh. So you're saying, so I would assume, the assumption I'm making is that a person who gives birth, a person X who gives birth to Y is older than Y.
Why should the person be older? In my case, it's younger.
This is the assumption I think. So
Why should you make that assumption? Why should that?
okay, so let's
Yeah.
say rather than saying this, let's say you have to be alive to give birth to somebody else.
Right. You have to be alive, otherwise you can't give birth. That is true.
Yeah.
Yeah,
So
that I can accept.
you have to have been born in order to give birth to somebody
That's right.
else.
Yeah, yeah.
A
Okay.
person X
Yeah.
who gives birth to Y
Mm.
has to have been born
Yeah.
at that point.
Right. Before giving birth, you should be born. Otherwise, how can you give birth? That is true.
Okay.
Yeah. So
So that means
this is not a definition, is it?
no, it's what's called an axiom.
Okay. So this is like a mathematical axiom,
Yeah.
something that you take to be true,
Yeah.
and we both agree accept that.
Yeah.
Okay.
So that means that your maternal grandmother was born before your mother. Was born when your mother was born. Was born before the time when your mother
That's
was
true. Yeah.
born. Yeah.
So let's see. Let me write that down. My maternal grandmother was born before my mother.
Person is born before.
Yeah. Yeah.
And by this, your mother who gave birth to you has to have been born before you.
Okay. Mother was born before me.
Yeah.
Yeah.
So your maternal grandmother had to have been born before you.
Yes. So she couldn't have been born when I was 5
When
years
you
old.
were 5 years old.
Okay. That you have convinced me in that one. So when mathematicians write this proved,
Yeah.
what we wanted to prove has been proved. That's when they write this.
Quadratic demonstratum or some
Demonstratum.
sort of Latin.
Yes.
Latin.
Quadratum demonstratum, which
Yeah.
means that which has to be proved
Has been proved.
has been proved. So this has been proved now
Yeah.
that the statement is false. But this is what you're using here is a mathematical
Yeah.
inquiry.
Hmm.
I wonder if it can be proved through scientific inquiry as well. The same thing.
I guess it could. So if you make a list of maternal grandmothers and their grandchildren,
Okay.
okay, with four
So-
numbers side by side.
Right. So for each maternal grandmother, you
Yes,
also
sir.
have
Yeah.
the grandchildren.
Yeah.
Yeah.
And now you call up pairs of grandchildren and a grandmother
Yeah.
and ask who's older,
That's right.
the maternal
Or
grandmother.
when were you born?
Or
Same
when were
thing.
you born?
Yeah.
We'll give you the same. So at that point you'll find out that you will not find any example
Huh.
when the maternal grandmother is younger than the grandchild.
Okay. So what you're saying is you take a very large
Large
sample of pairs of grandmothers and grandchildren.
Yeah.
And in each case you will find that the grandmother is older than the grandchildren.
Yeah.
Therefore you assume this must be true of the population of
Yeah.
grandmothers and
Yeah.
grandchildren.
So
But
notice
there could be some.
some grandmother who's
Yeah.
younger than the. It's not foolproof.
Yeah.
This proof.
So that means the scientific proof which you are giving now in terms of sample,
Yeah.
gathering a sample, looking at the sample and then extending that to the population, lacks the kind of certainty that mathematical proofs have.
Yeah.
There could be some grandmother, grandparent,
Yeah.
grandmother,
Yeah.
grandchild pair,
Yeah.
which is different.
Yeah.
Okay.
How the mathematical proof could be wrong is that this is not actually what you consider a grandmother to be in reality. This is just this
Yeah.
definition doesn't
But-
match.
But you have
But
proved that.
if you accept this, and this,
Hmm.
and some amount of some sort of relationship of transitivity between birth, then at that point you have to accept this.
Yeah.
If you accept the premises, you have to
Right.
accept the conclusion.
So this is like an earlier case that we
Yeah.
discussed in the previous unit.
Yeah.
That if you accept that John is taller than Mary and Mary is taller than John, whether or not that is true, we don't care. But it follows from these
Mary
two
is taller than
statements.
Bill.
That's right.
And therefore John is taller than
John, then yeah. Okay.
So that's similar here. So maybe the premises are wrong, maybe the axiom is wrong.
Right.
But if you accept the axiom and the definitions, you have to accept it.
So that's the nature of mathematical proof.
Yeah.